We're looking at section 13.1, exponential growth functions. So we want to identify the effects on a graph by doing some changes to our function for specific values of k. An exponential function is a function of the form f of x equals b to the x, where b is a positive constant other than 1, and the exponent x is a variable. Notice that there are no single parent exponential function because each choice of the base, b, determines a different function. So let's start by saying x is -3. So if we're saying f of x is 2 to the x, that means we're taking 2 to the -3 power, which is the same thing as 1 over 2 to the third. 1 over 2 to the third is 1 over 8. 2 to the -2 would be 1 over 4. We get 1/2. 1, and then 2, 4, and 8 as we take 2 to those powers. Similarly, if we have our base as 10 to the x, so 10 to the -3 would be 1 over 10 cubed, which is 1 over 1,000, 1 over 100, 1 over 10, 1, and then we'd have 10, 100, and 1,000. So if we graph the parent functions, okay, based on those points that we just had, we've got some small values down here. We'll have a value at 0, 1. Here's 1/2, 1/4. That 1 was 2, 2 was 4, 3 was 8. So this would be our parent function here. And with the base of 10, we had very small values down here, and then 0, 1, and 1, 10. So its parent function is a little bit steeper. What's the domain of each function? Well, the domain here is going to be, I'm going to write a little differently. I'm just going to say the domain is all real numbers. We can have any input for x because it's just the positive variable. Same thing for our 10 to the x. We can be all real numbers. Thinking about the range, if we look at our graphs, we'll notice that we're not crossing the x-axis. So that means we're picking y values that are greater than 0 in both of our pictures. What's the y-intercept of each function? At each function, we're crossing at 0, 1. And then what is the trend of each function? In both functions, the value of x increases, the value of y also increases. So they are both increasing functions. Will the domain be the same for every exponential function? Yes. The domain would be all real numbers since it's the exponent. We can have any value we want as our exponent. And it's an n. Will the range be the same for every exponential function, where b is a positive constant? So yes. When b is positive, the function will stay positive. A positive number to any power will stay positive. No matter the exponent value. Will the value of the y-intercept be the same for every exponential function? This is another one that's yes, because any number to the 0 power ends up being 1. So if we want to graph these types of functions, so for a given exponential function is a times b to the x minus h plus k, with base b can be graphed by recognizing the differences between the given function and its parent function. We're going to have the same types of situations here, same types of changes to our functions. So that h value is still going to be the horizontal translation. The k value kind of outside the function there is going to be the vertical translation, and the a represents the vertical stretch or compression, as well as whether it's reflected across the x-axis. Okay, so we're going to use 2 reference points, 0, 1, and 1b. So then how those change, 0, 1 becomes h comma a plus k, and 1b becomes 1 plus h comma ab plus k. The asymptote is normally y equals 0. For the parent function, it becomes y equals k if we are doing a vertical translation. So you can see the parent functions here. We've got both have the coordinate 0, 1, and then the function 2 to the x has a coordinate 1, 2. The function 10 to the x has a coordinate 1, 10. They both have a y asymptote at 0. So here we've got the function -3 times 2 to the x minus 2 plus 1. So the key things to notice, our base value is 2, so our parent function is the function 2 to the x. You can see that h is going to be 2. We're going to shift to the right 2. K is 1. We're going to shift up 1. And a is -3. So we're going to reflect across the x-axis as well as have a stretch by a factor of 3. So if we think about how that's changing our original coordinates, our x values we're going to add 2. Our y values will multiply by -3 and then add 1. So you can apply those changes to our two coordinates. Again, we're always going to have the coordinate 0, 1, and then we're also going to have the coordinate 1, 2, since our base is at 2. So applying those changes, you'll get the same coordinates they have here, 2, -2, and 3, -5. So k being 1 means we'll have an asymptote at 1, which means then our domain is still going to be all real numbers. Range, and we can see it from the graph, we're going to pick the y values that are less than 1. Since we were reflected and we have an asymptote at 1, our y values will be less than 1. All right, so I got cut off here, but our function is 1.5 times 10 to the x minus 3, and then minus 5. I can erase minus 5 on the outside here. So we're going to have a stretch by a factor of 1.5. Our x values are going to move to the right 3, and our y values are going to move down by 5. So I like to think about how these are affecting our original points. So our x values will need to add 3. Y values will multiply by 1.5 and then subtract 5. So if we start with the coordinates 0, 1, 0 plus 3 is 3. 1 times 1.5 is still 1.5, and 1.5 minus 5 is -3.5. We also have the coordinate 1, 10, because the base is 10. So 1 plus 3 is 4. 1.5 times 10 is 15, and then 15 minus 5 is 10. So those are our two coordinates we're going to use. We're going to have an asymptote at -5. Domain is going to be all real numbers. Range, we didn't flip, but we do have that vertical shift. So we shifted down, so our y values will now be greater than -5. So when we graph, we're going to have an asymptote at -5. We can draw that in. Then the coordinates of 3, -3.5, about there. And then at 4, 10. So our graph is going to look something kind of like that. So number 4 here, we should see we're going to stretch by a factor of 4. Our x values are going to move to the left 2. Our y values are going to move down by 6. So that's going to take our initial values. Our x values will need to subtract 2. Y values will multiply by 4 and subtract 6. So 0, 1 will become -2, -2. And then we'll also have the coordinate at 1, 2, because the base is 2. That will change to -1, 2. So in the next video, we'll finish up this problem and a few other things to finish up this section.